Hi, in this video we'll be talking about the real number system and arithmetic. This is the first part of a series of videos on these two concepts. Now, a number system is essentially a set of numbers together with the operations that we can perform using these numbers. So it describes a group of numerals and the functions we can perform with those numbers, like adding them, subtracting, division, and multiplication. Now in this part, we're only going to focus on the real number system. So to talk about the real number system, we have to introduce the idea of number sets. So these are just groups of numbers that we give names, and these names are very significant, especially when working with algebra and also when we are speaking in terms of the numbers. So when I tell you a type of number, then you should be able to work with it, or you should be able to know which operations you can do with that number. So the first type of numbers is the natural numbers. So these are also what we call counting numbers. Right? We are all used to these ones. Now, I want you to notice the notation here. This is what we call the blackboard notation. So it's like bold, but we simply show it with an extra line in the middle. Right? Then we also have whole numbers. So whole numbers simply put an addition of a 0 to the natural numbers. So we simply drop in a 0. You'll see with the notation there, there's a small 0 at the bottom. Then we have integers. So integers simply take the whole numbers and then we plug in the negative numbers. Right. Then we have rational numbers. So rational numbers are also what you might call fractional numbers. So they are those numbers that can be written as a number divided by another one. And I should also note that you can't divide by 0. That is undefined behavior. Then we have irrational numbers. So irrational numbers are numbers that are set apart, or numbers that can be set apart from the rest of the numbers that we have described above. So these are just the numbers that cannot be expressed as fractions. So this means their decimal numbers do not terminate and they do not repeat. So they are not exactly fractions. Then ultimately we have the real number set. So this group of numbers essentially involves all of the numbers above. Now, looking at the visualization of the real number system. Now, this is what we call a Venn diagram. It's simply used to represent relationships between sets. Right? Now, real numbers can also be represented on a number line. Right? But here, I'm using a Venn diagram. Now, look at the Venn diagram. The big rectangle here represents the real numbers as a whole, completely. And then when you go inside this big rectangle, you're going to see that I've divided it in the middle right here, almost in the middle. Then on the left here we have irrational numbers. Remember, these are set apart. They're those numbers that you can not write as fractions. Alright. And then on the right we have rational numbers. You see this bigger division here of the rectangle. Right. This is the rational numbers. Then inside the irrational numbers, you're going to find the integers, then the whole numbers, and the natural numbers. Notice how some of these number sets are contained inside other number sets. That's because natural numbers are also whole numbers. And natural numbers, again, they can also be called integers. So there's a significance to doing that. Okay, let's quickly look at an example here, just to get a gist of everything. So here, the question says we must classify these numbers. So we're given a list of numbers here. We have a -5, a 2, square root of 2, a half, a 0, and a pi. Right? We all know pi, right? Now, you should classify it as one of those number types here. Let's look at a solution together. Natural numbers. So natural numbers are the counting numbers, right? So these are the positive whole numbers. Right? Now when you look at this list here, you can see that 2 is a natural number. None of these are natural. We have a 2 there. Then what about whole numbers? Remember, whole numbers are just natural numbers plus a 0. So from the list above, we can see that 2 is still a whole number. A 0 is a whole number. So those are our only numbers, a 0 and a 2. Then we're going to look at the integers. Remember, integers simply extend the whole numbers. Now, let's look at them again. We have a negative 5. Okay, this is an integer. We have a 2. It's an integer. What about this 2 here? The square root of 2.5? No, they are not. A 0 is an integer. Pi? No. So we have 0, 2, and a negative 5. Now, let's look for rational numbers. Okay, remember what rational numbers are? Well, rational numbers are those numbers that can be expressed as fractions. Right? So this involves the natural, the whole, the integers, and the decimals. Like half here, for example. So 1 over 2 is a rational number. What about negative 5? Yes, it's a rational because it is equivalent to saying negative 5 divided by 1, which is just negative 5. So it qualifies as a rational number, right? So negative 5 is a rational number, 2 is a rational number. What about square root of 2? No, it's not. Half is a rational number. 0? Yes, it's a rational number. So here we have a 0, a 2, and a negative 5. Also half. Looking at irrational numbers, remember these ones are set apart, special. So we have square root of 2 and pi, right? Then, what about real numbers? Okay, can you identify real numbers here? Yes, we can. All of them are real numbers. Now, let's visualize this in our Venn diagram. Let's take these numbers and place them in our Venn diagram. So here it is. Now, remember, the bigger rectangle here represents the real numbers, and the irrational numbers are this Q prime notation here. So those are the square root of 2 and pi. You can see from here. So match them. Then when you look at the rational numbers, you'll notice that we have a 2 here, a 0, negative 5, and a half. All of them are rational numbers. Then inside the integers, we're going to see that we have a negative 5, a 0, and a 2. Inside this circle that represents the integers, right? And then when we go inside, we're going to see that we have natural numbers and whole numbers, which are just the 0 and the 2.